Hey there. So if you're a developer and you're ready to take your Python classes from just okay to actually really great, you are in the right place. Today, we are going to break down something that's key to writing clean, professional code, choosing the right type of method. Let's get into it.
You've probably gotten pretty comfortable writing classes, right? You define your methods, things work. But have you ever really stopped to think about why a method is the way it is? Knowing when to use an instance, class, or static method, that's one of those skills that really separates junior code from senior level, rock-solid code.
All right, we're going to start with the one you already know, the one you use all the time, the instance method. This is pretty much the bread and butter of object-oriented programming. It's designed to work with data that is totally unique to each specific object you create. Okay, the magic word here is self. When you create an object from a class, what we call an instance, self basically points to that one specific object. So when we call apply interest, self is what gives the method access to modify that one account's unique underscore balance. My account balance is different from your account balance, and self is how Python keeps track of all that.
Now this is where it gets interesting. An individual balance, sure, that belongs to an instance. But what about something like a bank's official interest rate? It'd be kind of crazy and super inefficient to store a separate copy of that rate in every single account object we make, right?
And this slide just nails the difference. Think of it like this. The instance attribute, self_balance, that's like the nameplate on your desk. It's unique to you. But the class attribute, interest rate, that's like the main address on the front of the building. It's the same for everyone who works there. And that distinction is absolutely crucial.
So if we have data that belongs to the class itself, it makes sense that we need methods that can work on the class, not just on one little instance. And that is exactly where the class method comes into play.
A class method, which you mark with this @classMethod decorator thingy, gets the class itself as its very first argument. And we always call it CLS. This is so powerful because it lets the method work with those class-level things like our shared interest rate. But honestly, its most common and awesome use is for creating objects in different ways, what people call a factory method. It's like having more than one recipe to build your object, depending on what ingredients you have.
And here is that factory pattern in action. We're not just stuck using init anymore. Now we can create a whole savings account directly from a dictionary. See how that fromDict method uses CLS to actually call the constructor? It's just a really clean, really flexible way to build your objects.
So, we've covered methods that need instance data, self, and methods that need class data, class. But what about a simple little helper function? Like, imagine a function that just checks if an account number has the right format. It doesn't need to know the account's balance, and it definitely doesn't care about the bank's interest rate. It just needs the number itself.
For these kinds of jobs, we have our third and final type, the static method. It is the perfect tool for these self-contained, stateless little utility functions that just logically belong with a class.
A static method is, well, it's really just a normal function that you've decided to put inside a class, mostly just to keep things organized. You mark it with @staticMethod, and here's the key. It doesn't get self or CLS passed into it. It knows literally nothing about the class or any of its instances. This is a perfect example. This isValidAccountNumber function only cares about the number string you give it. That's it. It doesn't touch any other data. We put it inside the savings account class because it just makes sense to keep all our banking-related utilities neatly organized in one spot. So choosing between @classMethod and @staticMethod really just comes down to one simple question. Does this method need to know about the class itself? If it needs to access a class attribute, or maybe call the constructor to make a new instance, then you need CLS. So you use @classMethod. If not, an @staticMethod is the much cleaner choice.
Okay, I know we've covered a lot, so let's just boil all of this down to a simple, foolproof decision rule you can use every single time you write a method.
Here you go, a simple 3-step rule. First, you ask, does this method need to access a specific object's unique data using self? If the answer is yes, you're done. It's an instance method. If no, move on to step 2. Okay, then does it need access to the class itself using CLS? If that's a yes, it's a class method. And if you've answered no to both of those questions, then what you have is a pure utility function, and that should be a static method.
Before we wrap up, I really want to warn you about a very common and super confusing bug that catches a lot of developers when they're first starting to work with class attributes. It's called shadowing, and it happens when you try to modify a shared class attribute, but you accidentally do it on an instance instead of on the class itself.
Now, Python doesn't give you an error, which is the tricky part. Instead, it does something sneaky. It creates a brand new instance attribute with the exact same name, which shadows or hides the original class attribute, but only for that one object.
Just look at this line of code. It seems innocent enough, right? We're trying to set a new interest rate to 99%. But here's the trap. Because we're doing it on a single instance, savings_account0, we are not changing the shared class attribute at all.
So, what do you think the result is going to be? Does this update the rate for everybody, or just for this one account?
And this output just reveals the whole mistake. See? Only the first account has that 99% rate. The second account and the savings account class itself are completely unaffected. This is why you must always modify class attributes directly on the class, like this. SavingsAccount.InterestRate equals 0.02.
You know, at the end of the day, using the correct method type isn't just about following some abstract rule. It's really about communicating your intent. It makes your code so much clearer to other developers, way easier to test, and far less prone to these subtle little bugs like shadowing. Honestly, it's a hallmark of professional code.
So, I'm going to leave you with this question. Think about the last class you wrote. Is there a little helper function in there that could become a @static method? Or maybe a chunk of code that creates instances from a file that would be absolutely perfect as a @class method, factory? Go take a look. Happy coding!